Well, I have a question. How about you?
Yeah. Yes.
Do we bring food tomorrow?
They will have a concession stand.
Were they stopping like in Huntington?
I want to bring some pretzels
Or something?
You might want to bring some snacks.
Hot.
Okay. So let's look at number 1. We're going to solve it by factoring. So this is like a quadratic. If you take the signs out, right, you've got 2x squared minus 3x plus 1. We're factor it just like a quadratic. So we'll have 2 parentheses equal to 0. What do we multiply to get 2 sine squared x?
2 signs. 2 signs.
and sign.
Good. 2 sine x and sine x. What do we multiply to get 1?
1.
1 times 1? Okay. Do I want positive ones or do I want negative ones?
Negatives.
Why?
Because there's a negative sign.
As Cruz said.
Got that negative 3 sine x, don't we? How do you get the middle term?
You have to multiply the insides and the outsides and add them together.
Add them together. So we have a negative sine x right there. And a negative 2 sine x. So a negative 1 sine x and a negative 2 sine x is a negative 3 sine x. Okay. So we factored it correctly. Now we want to solve. We want to get sine x's by themselves. But first, what do we do with these? Yes. Set them equal to 0. Good. So 2 sine x minus 1 equals 0. And sine x minus 1 equals 0. Now we're going to get sine x by itself in both of them. So what do we do first on the left?
Divide by 2.
Add 1.
Let's add 1 first. So 2 sine x equals what?
1.
And then
Sine x
divide
equals
by
1/2.
2. So sine x equals 1/2. How about on this side?
Sine x equals
Plus 1. Sine x equals 1.
Okay, so now what we have to do is find when is sine x equal to 1/2. What angle? And what angle is sine x equal to 1?
30.
Okay, okay, let's start with the 1/2 one.
30. Oh no, who said?
1/2 is 30.
And
Okay. Is that right? Is 1/2 30 degrees?
yes.
Okay, when is sine positive?
The first and the second.
Okay, all students take classes.
So it'd
So
be
30,
30 and
50.
So
150.
here and here,
Yeah, 30
Okay.
and 150.
this would be 30. This would be 150. Unfortunately, they don't want it in degrees. They want it in radians.
So it'd be pi over 6 and 5 pi over 6.
Okay, how did you get 5 pi over 6?
Because it's 1 pi.
before. It's 1/6
Pi.
before pi 6 pi over 6.
Okay. That's one way to get it. It's the one right before pi. So it'd be 5 pi over 6. Another way, y'all have these memorized?
Yeah.
Okay, good, because you're going to need them. So, x equals pi over 6 and 5 pi over 6. Squeeze that in there. Now we have to do the sine of x equals 1. When is sine of x equal to 1? Good. So I heard somebody say it. Pi over 2. What is this up here?
0 over 1.
0, 1. And sine is the y, which is 1. Okay, so it's equal to 1 here. Down here it's equal to negative 1, so that's not one of them. Pi over 2 is really our only answer for that one. Okay, so our complete answer is all 3 of these. X equals pi over 6, 5 pi over 6, and pi over 2. Okay, so now number 2. First thing we have to do is set the equation equal to 0. So how can we do that?
Subtract the divide.
Actually, we're going to subtract this.
Subtract it.
So we'll have 2 sine x cosine x minus square root of 2 cosine x equals 0. We do that so we can factor. Now, what is common in both of these?
Cosine.
So we can factor a cosine x out. What does that leave you
2
with?
sine
2 sine
x.
x minus square root of 2.
Good. Everybody okay with that?
Mm-hmm.
All right. Now we set each one of them equal to
0.
0. So cosine x equals 0, and 2 sine x minus square root of 2 equals 0. Okay, then let's go ahead and solve the sine x one.
So add the square root of 2.
Add the square root of 2.
And then you divide by 2 on both sides.
Square root of 2
Yeah. Square root of 2.
Good, divide by 2 and sine
45
x.
degree.
That sounds familiar, doesn't it? Square root of 2 over 2.
45 and
135.
35,
No,
which would be
there-
pi
so,
over
yeah.
4.
Okay, let's look at the sine of x equals a positive square root of 2 over 2. So that would be in the
45.
first and second quadrants, right? Sine is positive in those. And they're 45. What's
Pi over
Power
4 and
Okay.
3 pi over 4.
pi over 4 is a 45, and
3 pi over 4 since it's 7.
so x equals pi over 4 and 3 pi over 4 for this one. What about cosine of x? When is it 0?
At
Pi
90
over
and
pi.
2, 3 power 2.
0, 1, 0, negative 1. So cosine is 0 in both of those, and that's pi over 2 and 3 pi over 2.
And then we have to do them all.
Right.
yeah, just skip that first.
Yeah, I
Put
know.
them all together first.
You can. I'm going to go ahead and put it, though, just so we know where they came from, okay? Okay, number 3 is already set equal to 0. Can it be factored the way it is?
Yep.
Yeah.
I
Cosines.
was saying,
Cosine,
And
Cosine x and cosine
okay.
x. 5 and 1, both positive.
Okay, 5 times 1 would give you 5.
Positive because you need 6.
Okay, you need, so you get 5 cosine x plus 1 cosine x gives you 6 cosine x. Okay, then what do you do?
So both equal 0.
Okay, so cosine x plus 5 equals 0, and cosine x plus 1 equals 0.
That's negative 5.
Cosine x equals
Okay,
negative.
does cosine x ever equal negative 5?
No.
Empty set.
You just mark that thing out.
Yeah,
Ooh.
that's an empty set. There's no way to get
So that
cosine x
cosine
equal to
x
negative
what
5.
it is.
that was a
Okay.
lie.
Empty set. Get out.
What about negative 1 though?
Pi.
Pi, good. Is that the only place?
Yeah.
Yes,
Yeah.
there's your answer.
X equals pi.
Not too bad, is it?
Yeah, pi day again.
We're done with pi day. Thank goodness.
Here it is, the page flip.
You're gonna
A
say
page
Patrick's
flip.
Day party.
It's really not bad. Okay, this is already set equal to 0. So what can something be factored out?
Cotangent.
Cotangent squared, good.
Yeah.
So cotangent, oh, no, that wouldn't be cotangent. What would that be? 1, good. 1 minus,
Cosine squared x.
good, equals 0.
You make that cosine squared x into something?
Put that into sine.
Not yet. Not yet, but okay. Okay, as long as we factor and then set each one equal to 0, then you can start doing stuff like that. Okay? So what?
Cotangent squared x equals 0 and
Okay.
1 minus cosine squared x equals 0.
Okay, this is what you can't do. I want to make sure you understand what you can't do. What would that equal?
Sine
Sine squared x. So you have cotangent squared x, sine squared x equals 0, right?
Yeah.
And then what's cotangent squared x equal?
1 minus
X over
sine
y.
over, or cosine over sine. And so you'd be able to cancel out your
But
sine.
don't
That don't cancel, right?
Can't.
Okay, don't do that because then you're going to lose those answers if you do. So that's why we don't do that.
I think just leave them like that.
Yeah, you want to do this. Now, once you set them each equal to 0, then you can change them. Okay?
You really don't have to.
No, you don't. You're right. Cotangent squared x equals 0. We need to get cotangent x by itself. So what would we do to
Square root.
And remember, when you do the square root, you have to do the plus and minus. But there is no plus and minus 0, is there?
No.
So that doesn't really matter. cotangent x equals 0. Now you could change this to sine squared x. I'm going to not change it just to show you that you don't have to. Okay? I'm going to move the cosine squared x to the right side so it's positive.
1 equals cosine squared.
All right. And then, what would you do to get cosine x?
Square
Do the same thing
root of 1.
So we get plus or minus 1 equals cosine x. So we need to know when is cosine x equal to positive 1 and when is it equal to negative 1. You could have also, we could have factored this too. How would you factor that?
for cosine.
1
Cosine.
minus cosine x
Plus
and
1 minus
1
1.
plus cosine x, which would give you the same thing as cosine x equal 1 and cosine x equal negative 1. Okay. So, and then you could have also put sine squared x equals 0. You'd have sine x equals 0. And when is sine x equal to 0? At two places, just like this. Okay. At the same place that cosine x equals positive 1 and negative 1. So it works.
Pi and 2 pi.
Do y'all agree it's pi and 2 pi?
I mean, yeah.
Nah,
1,
I think
0.
pi-
Negative 1, 0. And 0 too, right?
Zero.
Okay.
Oh, you're gonna put 0?
Yeah, it's both of them. Because it said from 0 to 2 pi.
Well, it's all like one thing.
Okay, what about now here's a tricky one.
Cotangent equals 0.
Okay,
X over
what does
y.
tangent equal? Y over x, x over y,
X over
y over
y.
r.
Y over X.
Tangent is
Y over X.
y over x. Cotangent is
X over Y.
So it'd be
Cotangent
Pi over
is
2 and
0.
3 pi over 2.
mm-hmm. Because you're going to have 0, 1 here and 0, negative 1. Okay, and when for cotangent to be 0, you'd have x over y or 0 over 1, which would be 0.
So pi over
Down here, 0 over 1, negative 1 would also be 0. So what did we say?
Yeah.
pi over
Answer.
2 and 3 pi over 2.
Just all your quadrantals pretty much.
Okay,
Yeah.
now cotangent, anytime you have a reciprocal or something in the bottom, like tangent, cotangent, cosecant, and secant. Okay, you have to be careful with those. Okay, because let's plug in 0 up here. Cotangent of 0, that's over here, isn't it? Now cotangent is what? X over y. What happens when we do x over y here?
It's undefined.
It's undefined. So we can't use that one. Now if we plug in pi is over here. What happens when you do x over y over here?
It's still the same.
It's undefined. So you can't do that one. Okay?
Just erase that 0.
And then the
Oh,
pi is 2 pi.
2 pi's on the right,
Sorry.
pi's on the left.
2 pi's over here, same thing though. Okay?
Why are we crossing?
Okay. Did you just miss that whole thing?
Yes.
Okay.
Yeah.
Right. We're plugging, okay, we're saying that these would be answers, right?
Yeah.
And so you would plug pi in here for x. And you do the cotangent of pi. Okay, right? Minus the cotangent
We're
square
pretty
of
much
pi.
going to plug them all back in to see.
Okay, only on cotangent and tangent and secant and cosecant. Okay, those are the only ones you have to check because they're the ones that have something in the bottom and they could be undefined.
Okay.
Okay? So cotangent is x over y, right? Everybody okay with that? All right, so if we use 0 or 2 pi, that's right here, isn't it? And we did x divided by y, what do we get? 1 over 0, which is undefined. So we can't plug 0 or 2 pi in here. We'll get an undefined. Right?
So those aren't real answers?
No, we got it right. They're not. We have to mark them out.
So our
Okay?
answers
They
are
were
only
possible
pi over
answers, but they did not. They do not plug back in.
What are the answers? There is none.
These.
Pi over 2 and
2.
3 pi over 2. Well, do those work with the cotangent?
Well, yeah, because
cosine?
that's what we did here.
Or with the cosine, do they work with that?
They don't
Cosine
have
will be.
to.
They don't
Yeah,
have
they do have to, and cosine's fine
to.
because you don't have anything. Cosine is x over r.
Okay.
Okay, radius won't be undefined. That won't be undefined.
Okay.
The only thing that could be undefined is cotangent or tangent or cosecant or secant. Okay, those are the only ones that can be undefined. So like these back here, these were all sine, cosine, and sine and cosine. We didn't have to check those. Okay,
So anything that doesn't have R on the bottom?
right. Anything that doesn't have an R on the bottom. That's exactly right. Okay, okay, let's try number 5. It's already set equal to 0, so,
They both have cosecant.
okay, so cosecant x times what?
Cosecant plus 2.
Cosecant x plus 2 equals 0.
So they're both equal.
So cosecant x equals 0, and cosecant x plus 2 equals 0.
Cosecant
So cosecant x equals
equals
negative 2. Okay, we got to be careful. We can't just mark this one out because it's negative 2.
It's close.
One of the reasons is there's 2's in a lot of our answers, right? Like 1/2 or square root of 2 over 2. Okay, and cosecant is equal to what?
1 over sine.
Sine of 1/2.
1 over sine, right? Where is my x going here?
Exponent.
Okay. So do y'all agree that 1 over sine x equals negative 2? Okay.
Wait.
We just
Put a 1
changed
over it, cross multiply.
cosecant.
Okay.
We just changed cosecant to 1 over sine.
And if you flip it, it's
That's an identity. Okay. And then what?
flip it, it's sine x equals 1 over 2, negative 1/2.
How do you flip it?
So that can,
Flip this one and flip that one.
so it is a possible answer.
You can do that.
I mean,
Oh,
I'm so
whoa,
confused
whoa,
on the
whoa.
flip.
Okay, let's cross multiply. That's confusing them. Okay?
Why you split it?
Negative 2 sine x equals 1. Divide by negative 2. Sine x equals negative 1/2. All we do is flip both of them.
Okay.
Okay, you can do that.
You can flip both of them, multiply straight across.
You don't multiply, you just flip them both.
And
You
then
get
Just if it's
Sine
cosecant,
x
you flip it to
equals-
make sine.
1 over 2.
right. Where's the, here, this is a negative, isn't it?
That's
Okay.
Ooh.
Okay, so where is sine x equal to negative 1/2?
5 pi over 4? 5 pi over 4 and 7 pi over 4.
4.
Or
6.
Oh,
It's a 30 degree, right?
Minus pi.
6.
That's 7.
7 pi over 6 and 11
That's
pi
fine.
over 6.
There you go.
Go, George.
It is what it says.
Hey, stop it. Rama. Okay, so cosecant x equals 0. Where does that, what's cosecant x equal to?
1 over sine.
1 over sine x equals 0.
You okay with that, Mimi?
Cross multiply. What happens when you cross multiply
Where is
these?
sine undefined?
You get sine x times 0. What's that? Equals, what's 1 times 1? Does that make sense?
No, so that's actually the one you're interested
Yes.
in. No, wow.
Okay, so their answer is right here.
Okay. Still like understand whole process.
Which part? The number 4?
Number 4,
Number
yeah.
4. Okay, because if you, these are answers to this. We're trying to find what x could be to make this true.
Right.
So if you plug these back in, you get undefined here. Okay, that's why we have to cross them out. If you plug any of these back in, you're not going to get undefined. Now we might ought to check this one. Cosecant. Okay, cosecant of what degrees are these?
30.
Cosecant is 1. Oh no, we did sine, so we're fine. That's right. We started out with cosecant, so it's okay. Okay, here, Josh, see the difference. We had, right here, we had cosecant equals negative 2, and we found what it was.
Right.
Okay, and you have cosecant over here. This one up here had cotangent and cosine. Okay, we weren't dealing with, if this had been cotangent over here, we wouldn't have had to check it. Because we would have found the answers for cotangent. We were finding the answers for cosine, and so we had to check to make sure it worked for cotangent. Okay, here they were both the same, so we were okay. Okay, that didn't help any, but that's okay.